Okay guys, in Itsu, here's what I did. I've reduced the Arduino off time by 1/4 of the off time it was. So we have basically 4 times the amount of pulses. I couldn't go and give you more pulses because basically that is the maximum right now, and that's 4 times the amount of pulses. If I go any lower, the this particular oscilloscope goes into scan mode, meaning there's no data reading when it goes into scan mode. So that is the lowest that I can go now, but I've got a lot more samples. Okay, and the other thing I did too is I reduced the input voltage. What that did is I was able to bring the voltage divisions across the resistors up at the 100 millivolt range. So previously to that I was in the 500 millivolt range, and it wasn't doing very well to do any kind of calculations on CVR1. So basically I'm underdriving the circuit from what I was showing. So let me go into here and we'll just look at one single pulse. So as you see, what I did is I adjusted it to maximize the window. It's still within the window. The pulse doesn't go above here and it doesn't go below there. And there is the CVR1. So that's CVR2 in blue, obviously. And so now I will scan out. And what I've noticed with this scope anyways is that once you've got a certain amount of samples in the window, you start looking at the calculations here, and as you go down, okay, and now I've got more than double the amount of samples. If that math stays stable, then you've got something that's reading pretty good. And as you see, it's pretty stable right now, and I'll go down and give more samples again, and as you see, that didn't change very much. And that's all I can give as far as samples. If I go any lower, it goes into just scan mode and no data is visible. Okay, so I will put the I will add those scope shots there. So basically the circuit functioning at this level here, I'm putting in 38 volts at 126 milliamps, which comes to 4.75 watts input. And my inductive discharge collection from my cap here is going across a 270 ohm resistor, which has about 29.8 volts across it, and that comes up to exactly 4 watts. That resistor has been measured with my precision multimeter, and once it's actually hot at that temperature, and it is in fact 270 ohms. Okay, so yeah, and this is my setup here with my two metal film 1% precision CVR resistors that I'm using. These are 2 watt metal film 1% resistors, and again I use my high quality fluke meter here to measure that. Okay, this is a, I don't know, $600 or $800 meter, and it has a 50 ohm or less reading, so I can read down to milliohms, down to 1 milliohm. And I have super short terminals on that, so there's no resistance. Basically, when I short those two probes, this goes down to 0.000. So I was able to definitely make sure that those two resistors are the same. And so you're now seeing some good scope data now, and it is obviously showing more current on CVR2, and that's what we're investigating. So anybody else that haven't been following this, that are kind of popping in now, this here is my MOSFET switch, okay, and it's an opto-isolated MOSFET switch. So I'm using a Arduino as a signal generator input to the isolated side of the MOSFET switch, meaning there's no possible connection between the logic to the switch side. Okay, so and then I have a high quality Schottky diode here. It's I think it's a 50 amp up to 1200 volt diode, and there you go. That is the circuit. 100,000 microfarad capacitor and 27,000 microfarad capacitor. And I've talked about the resistors. Now the other thing too is I have noticed as well, just like Brad, that basically the resistor is warmer, and it's not doing it now. Okay, there you go. 75.5 degrees. You saw that on the meter there. There you go, 75.5, and this is the input resistor, 74. Okay, back to the CVR2, 75.5, and now back to CVR1, 74. And if I just measure the surface temperature of like anywhere on the capacitor, it's basically at 74, 73.5. Okay, or anything in this lab, for instance, 73.5. So everything in the lab is at 73.5. So there you see CVR1, 74.5, and 75.5 CVR2. So there is a temperature difference measurable as well between those two resistors, even though they're super small resistance value. But definitely can measure something. So I thought that would be interesting. And as well, this toroid is just an off-the-shelf toroid. I'm just using just an inductor I pulled off the shelf. Nothing special about it. There's no magnets or nothing involved here. All right, so that's it for now. Thanks, bye.